Hi, I am Bishra Asan, and together with Lena Hegeman, Jiang, and Anchal Asvirta, we would like to present suggesting colors for UI designs with graph neural networks. Designing color palettes for UIs is a fundamental and time-consuming process. It often requires multiple iterations, and whenever a change is made, the harmony of the palette should be protected. We propose a novel content-aware graph-based representation that can infer suggestions for color palettes and color assignment. Our work makes the following contributions. A novel graph representation for UIs with a focus on colors, which incorporates the types of elements, their associated colors, and the relationships between UI elements. A graph neural network method for learning the graph representation by recommending both color palette selection and color assignment to UI elements. We implement our method to suggest and assign color palettes based on a one color change made by the user within the palette. This approach is applicable across various scenarios, such as mobile and web UI design. How to represent graphical designs as graphs. Here you see a simple example for converting a design to a design graph. Each design element in the graph has a corresponding node, and the numbers on the design correspond to their node representation. Each node has two features, color representation and the type of the design element as one hot vector. The edges of the graph have relative distance between elements as the edge weight. In color representations within graph nodes, we utilize a one-hot vector to encode RGB color information. RGB color space is transformed into a 4x4x4 cube space to create color classes. Each color class is determined based on the ranges each RGB channel falls into. For instance, in the image, blue is mapped to color cube 64. This information is then converted into a one-hot vector, placing a 1 in the 64th position. To construct the feature vector within a node, this vector is concatenated with the one-hot design element type vector. Our graph neural network architecture comprises a graph attention network and a linear layer. The output is a 1x64 logits vector. After softmax, we can select a color from top K color class choices, and we pick the top third class. Then we concatenated it to the remaining RGB values in the palette. Subsequently, a linear regressor maps this vector back to the continuous RGB space. Each RGB color is mapped to its corresponding class and concatenated with other colors in the palette. Then, the regressor predicts the exact RGB value for a color. Autocompletion of the palette in response to a color change follows an autoregressive approach. For example, if a user changes the yellow color here to a gray, this change is applied to all elements having the same yellow color in the graph. Following a predefined sequence, a node is masked and the color is set to 0, 0, 0. The GNN then predicts a color class for this mask node, and this class is mapped to an RGB color by the regressor. The predicted color is assigned to the mask node, and the process repeats for the next mask node until all palette colors are updated. Users can also lock colors they don't want to change. We explored the impact of masking order following a color change. We found that arranging colors by text, background, and decor yields the most diverse palette. Thus, we used it on our experiment. While other orderings consistently produce palettes with similar hues, they may also be favored depending on the context. Here are examples of a real-world user interface design from Figma. We update the color indicated by star. We visually assess the harmony and the contrast with the Web Content Accessibility Guidelines. The palettes demonstrate various harmonies with palettes 1 and 3 using similar schemes and blending neighbor hues on the color wheel. Palettes 2 and 4 employ complementary schemes. In palette 4, you can see the juxtaposition of cool and warm hues for a bold visual, while palette 2 achieves a calmer appearance with muted complementary colors and neutral tones. The web page design depicted in this figure showcases compelling harmonies. Palette 1 and 2 exhibit similar schemes with lower saturation, while palette 4 presents a complementary theme. Palette 3 is a monochromatic scheme, combining shades of the same hue with neutral grays for a simple and clear design approach. We see a warm-toned palette in 4, cool-toned in 1, and combined schemes at others. These diverse harmony types and vibrant palettes hold promise for offering designers meaningful alternatives. When it comes to measuring the conformity to VSCAG, we occasionally notice some issues related to the contrast between background and text. The overview title and the tree-graph paragraph text don't meet the contrast requirements, which is expected due to the dataset's emphasis on harmony over contrast. Improving the contrast between text and background during the training could mitigate this issue. Number of colors presented in graph is also fixed, and our labeling system does not reflect all types of design elements present in the UIs. Also, we observe performance drop on more complex designs such as this one. Thank you for listening. Feel free to reach out to us for any additional inquiries or questions you may have.